All right, everyone, thanks for joining us. We're going to get started here. We're here today to talk about Docker and Kubernetes log collection and monitoring. So we'll start off with some quick introductions. I'm Brandon Mensing. I'm a product manager here at Elastic, focusing on the Beats product. Been here for a couple of years, and I'm excited today to tell you more about Beats.
Hi, everyone. My name is Carlos Preciados. I'm a software engineer. I'm working on Beats and have been focusing on some of the features we're showing today.
Great. All right. So before we really get going, let's do a couple of housekeeping items. So if you are hoping to see the slides of the recording later, no problem. Those will come to you in an email if you have registered, and they'll be on our website. So it's all available afterward. You can also chat with us live right now. So of course, a lot of you folks already know this, and you've already joined us in our IRC room. If you're not familiar, if you haven't done it before, if you're not sure what IRC is, no problem. Click on that join the chat link, and you can create an account right in there and start chatting with us. It's very simple and easy to do. You just need a name. You don't have to properly sign up or anything. And last but not least of our logistics is if things look blurry. This is going to be a problem, and we'll remind you when we start doing the demos that you can actually change the resolution in the YouTube player. So click the little gear icon and choose the higher resolution, and you should be good to go. All right, so first, let me tell you about Elastic and our products. First and foremost, the Elastic Stack. These are 100% open source products that you probably already know and love. Elasticsearch is the core of this picture here. It is the place where all of the data is stored, searched, and analyzed from. And then we have the products that ship the data in, which are Beats and Logstash. Beats are lightweight shippers, and I'll give you a little more detail on those. Logstash is a Swiss Army knife of data enrichment and modification and all of these sorts of processing capabilities and delivery to Elasticsearch and other places. And then Kibana, of course, is your window into the Elastic Stack, provides you the ability to do all sorts of charting analysis and other functions that are UI-based. It's our UI for everything for the Elastic Stack. In addition, we have XPack. XPack is our commercial offering, which is a single install that extends the Elastic Stack. Gives you security, alerting, monitoring, reporting, graph, machine learning. It's quite a mouthful of things to say, quite a lot of features in there. It is on a subscription basis, but the really good news about this is that not only can you try it all for free today, you can go and get this all yourself. You don't have to wait for us or talk to us to give it a try. But there are also features of this, such as monitoring that are part of our basic license, which means that you can use them for free as long as you'd like. So go and give that a try today. Highly, highly recommend it. Lots of great stuff in there. And if you'd like, you can also try out Elastic Cloud. This is our hosted offering of Elasticsearch and Kibana, including XPack features. And what's great and what I love about this is that it really is the simplest way to get a cluster, because all you have to do is point and click and you get a cluster inside of the cloud. And if you want to make it bigger, if you want to upgrade it, that's just a couple of clicks away as well. This is a very managed, very seamless experience that we think you'll really enjoy if you haven't tried it out. So go give that a try today. It is available inside of the AWS regions and Google Cloud Platform as well. So you can choose where that's deployed. And it starts at just $45 a month for a paid cluster. So you can try it for free, and it's cheap to keep going, especially if you have a smaller use case. So lots of great options there with Elastic Cloud. And if you'd like, you can also have that kind of experience inside of your choice of machinery. So if you'd like to have something like a logging as a service for your entire organization, but you want it to run on your private cloud or in your server closet, you can actually do that by installing Elastic Cloud Enterprise. Elastic Cloud Enterprise seeks to bring you that Elastic Cloud experience on the hardware of your choice, on the infrastructure of your choice. All right, so I've run through quite a bit there, and I want to focus for a moment on Beats. There are 6 Beats today, as well as many, many community Beats. We have over 40 and growing all the time. But I want to tell you a little bit about these because that's what we're focusing on today. In particular, we're going to be focusing on Metric Beat and File Beat and some features of those that we released in a couple of the more recent versions. Beats are lightweight shippers. They're written in Go and they're compiled to your system. So they run very efficiently and very quickly. And their goal is essentially to get the data from the very edge where it exists on a machine, on a network, and bring it into the Elastic Stack. That's their primary goal. And of course, they can also ship to Kafka and Redis if that's how your infrastructure is set up. And as you can see here from the slide, our 6 beats today collect from various kinds of data locations. So you can get data from the application layer of your network with PacketBeat. MetricBeat will pull systems and services to get health and status monitoring information about what's going on with those systems and services. If you have logs inside of the Windows Event Log system, WinLogBeat will help you with that. AuditBeat, which is the most recent, will get data from the Linux audit framework, as well as do file integrity monitoring on other OSs. AuditBeat's the most recent great option for a lot of folks out there using AuditD. FileBeat, our most popular, is going to tail log files. That's its primary goal. And we'll see more on FileBeat today as we try to get data from Kubernetes and Docker. And Heartbeat, which is going to allow you to do some uptime monitoring, especially of distributed service architecture, being able to monitor the endpoints between each other to make sure that they're all up and available to each other. So again, quite a lot of detail, I realize, but these are all of our beats today, and I want you to see the full suite of options. You can go and try all these out now. They're all open source, and we're always open to hear feedback on these. All right, so let's talk about why we're here today, and let's frame the problem. I'm going to start at a point that's maybe a little bit too simplistic for folks that are already familiar and have Kubernetes and Docker deployed, just to make sure that we all understand what the problem is and the reason that we built these features inside of Beats. So in a really classic, old school sort of way, if I had a box in a closet and it's running Ubuntu, if I install something on it represented by this little circle, that's a service that I want to run on that box. That's great. That's the really old way to do it. I might actually SSH into that box or pull up the terminal physically on it and start typing away to install that service. And over time, I might decide that I need several of these. And as that box becomes swamped, I might need more boxes and more boxes and more boxes, right? This is the the problem that we had maybe 10 years ago, 20 years ago. This is obviously not how we do things now. We wouldn't manually go into all this. But if I wanted to monitor all of those services in a really classic sense, I might install agents on those machines, such as FileBeat and MetricBeat, in order to get data from all of these different services running on there. And in order to do that, I would either manually configure the FileBeat and MetricBeat YAMLs, or in the more recent, more modern sense, I might say have some orchestration in Chef, Puppet, Ansible, and get quite a bit more fancy with automating the fact that having an additional service on these machines, just works and just shows up. I don't SSH into them and manually do it. And also, I would have FileBeat and MetricBeat configurations, which I manage and which are specific to these services. But even this situation with Chef, Puppet, Ansible involved is not nearly as dynamic as the problem of having Docker and Kubernetes running many ephemeral services and software that you write, which you need to collect data from. So it creates a different set of problem because while here, I already know that what I have to do is modify the configuration on FileBeat and MetricBeat for each machine. When we flash forward into a Kubernetes deployment and we talk about these circles as containers instead of being individual services, we raise a lot of questions, especially as this becomes a moving photo of the infrastructure as things are being deployed. And so some of the questions that come up that we started to work through even before we built additional features, when folks would ask us, where do I install a beat? Do I put the beat inside of the container and have it pull data from within, or do I put it on the host itself? Maybe that makes more sense. And then what do I do about the other hosts? Do I actually put it in every host? Do I have a beat inside of a container on its own on each host, or one per service? There's a lot of potential ways to go there. So we'd get this question a lot. We'll go into this a bit with Carlos's demo. But then the really dynamic part of this becomes, what if I wanted to collect all of the data from all of the different containers running on there, right? Would I configure to have my beat, would I manually configure the beat to point to all of those different services? That doesn't seem reasonable. especially because additional services might show up at any moment. So how do I make this work dynamically? And of course, also, by the way, I need to know about how do I get to the data from the Docker Kubernetes mechanisms itself, right? So there's a lot of questions here, and basically that was sort of my goal in the opening here, is to frame the scope of this problem. You have a lot of ephemeral services. You need to get logs and metrics from all of the services running inside of the hosts, and then of course logs and metrics about the orchestration that's going on itself. So that's the problem set. How do we do it? And the short answer to how we do it is, take it away, Carlos. Let's get into it. I'm going to get rid of my screen share here and exit out of something. So sorry for the little hangout Zoom. There you go. Take it away, Carlos.
Thank you, Brandon. That was an awesome introduction to the problem. So yeah, thank you everyone for coming. And yeah, let me talk a little bit about our journey in Bits with Docker and later with Kubernetes. We started supporting Docker, so you could monitor it using MetricBits a long time ago, in somewhere in the 5.x timeline. And then we started to have some users. At some point, we got contacted by some people in the community. For instance, a team in eBay were using Bits internally, and we're starting to use it to monitor their Kubernetes. And that was really cool because that gave us a lot of input on what's needed for these use cases. And also in this case, they contributed a lot of code. So we are thankful for that. And I think it was great because for us, it was very good input for deployments at a scale, at really big scale of Kubernetes. And yeah, these people is using it in production. So that's really cool. So we started working on Kubernetes something like last year, at the beginning of the last year. And I'm going to talk about all the features that we have present today in Bits for Docker and Kubernetes. So what's the challenge, or what's different with containers? Brandon explained it so well that I'm not speaking too much here, but you know, when you are doing containers, everything becomes a moving target. As we saw, it's very different from an old school server where you deploy probably your service. I don't know, I deploy a MySQL that is going to be sitting there for probably years, and I only need to configure the agent to monitor it once, and probably I can forget about that server. Also, configuration management tools helps with this task. Maybe if you are working on a bigger scale or with virtual machines, but still things are pretty static. With container, this changes. If you are using a container infrastructure, probably with an orchestrator on top, like Kubernetes or maybe Docker Swarm or whatever, it doesn't matter. Things are moving from one place to another. It's very common that you scale a deployment and that creates new containers in some host that you cannot predict. And yeah, basically everything is pretty dynamic. So we need specific tools to track things down, so we can still monitor what's going on without losing track. And this is a toolbox that we have put in Bits, in all the different Bits, that you can leverage when using containers infrastructure. We are going to be talking about logs, like retrieving logs from your containers, also about retrieving metrics and doing monitoring. So yeah, modules, Docker logs input, metadata processors, and auto-discover. These are the 4 major tools that we provide within Bits. You can use them together or only use one of them. It depends on your use case. And you can mix all this with the existing features of Bits. And we can see this later on in a demo I'm doing. So let's get started with modules. On the left, we can see a dashboard for our Docker module, and on the right, we can see the dashboard for our Kubernetes module. Basically, this is a very easy way to get started monitoring your containers infrastructure. When you are monitoring containers, you need to monitor on many different layers. One of them is the system, the underlying host, where all the Docker containers are running. Then the Docker the Docker infrastructure, the Docker level, where you monitor Docker itself and all the containers running in that host, and also the orchestrator layer, in this case Kubernetes, where you monitor things like the counters for how are my deployments doing, for instance. So we provide two modules to do that, both Docker, also system, and Kubernetes, to monitor them in a really easy way. Also, we can talk about logs. We created a Docker log input that is able to understand the native logs from the Docker default JSON file driver. So the idea is that Docker, when you run a container on Docker, Docker takes care of writing all the standard output for that container, the logs from that container, into the host file system, and it writes it in an existing format. This is the format where you get the lines in JSON documents and get information, not only the message, but also what's the stream, like a standard output or standard error, and also the time where that line happened. We created an input, a prospector, to parse that, and that understands that format, so you can benefit from it and do things like, for instance, if you are outputting JSON in your logs, you can understand that after parsing everything with this Docker prospector. We will see that in the demo. Then something really important when you are getting information from containers and monitoring them is metadata. When you are monitoring things that are so volatile, you need extra information to understand what's the context of the information you are seeing. Let me put an example. When you are getting logs from different containers, you want to know what was the host where they were running, or maybe what was the container ID or the container image version, things like that. Through metadata processors, we can enrich the events that come from bits with really useful information that will help you later on to navigate these logs or metrics. In this case, at the moment, we have 3 different processors that help you add in metadata. The first one adds information about the cloud you are running in. The second one adds information about Docker. And the third one adds information about Kubernetes. This is an example of how a file bits event, so this is a log, looks like when you are using these processors. You could be using maybe only one or the 3 of them. It depends on your use case, but all the metadata will be added to the documents coming from bits. So in this case, you can see that we have not only the timestamp and the message, that's the standard thing that you will get from FileBit, whether you are using it with containers or in a common system. But thanks to the metadata processors, you also get a lot of information about the context of where this message came from. So thanks to that, we can see that this came from a Kubernetes or a container running in Kubernetes. The pod name was FileBit. The container is FileBit, and it's in the name kubesystem namespace. And we can also see the labels that were applied to that container. That's really useful then later when you want to navigate these logs, and we will see that in the demo. Also, we can see, thanks to the cloud metadata processor, that this was running in Google Cloud, and that's all the details about that specific machine. This is how metadata processors work. In this case, this is the add Kubernetes metadata, but the Docker one is pretty similar. Basically, when you are using these processors, Bits is constantly talking to the Kubernetes API server, polling for events on the different pods. So we are especially interested in events where a pod starts or stops. And every time that happens, we update an internal table where we correlate the container ID with all the metadata that we saw about that pod. So later on, when we are reading logs from the file system, we get the container ID, go to this table, and retrieve the metadata for that pod. This is a very efficient way of doing this because we don't have to contact the API server for every log line. We just get the events from Kubernetes and update an internal cache. So we don't have to hammer the API server. Then when we detect what's the where is the metadata for that log line, we enrich the full event and send it to Elasticsearch or Logstash. So you get all that information. Now let's talk about auto-discover. This is another useful feature you can use. And it was introduced in 6.1, so it's pretty recent. The idea of auto-discover is that it allows you to define a set of conditions that you want to match against the containers that are running, and define a set of configurations you want to launch when these conditions happen. So this allows you to create very dynamic configurations, and this works both with file bit for logs and metric bit for metrics. And the idea is, as you can see in this example, is I want to define a condition. In this case, if a Docker container is launched and the container image contains etcd, I want you, metric bit, to launch this module for me. And I give you the configuration of the module as I want it. So this is all I need to tell metric bit, and it will take care of launching the module whenever I want it. And look at that data.host. I'm about to explain what that is. So this is how auto-discover works. Basically, Bits is talking to the events API in the same manner as we saw with the metadata processors. And for every new container that starts or dies, we create an auto-discover event. This is something internal to the Bit, with all the useful information you may want to know about that container. So as you can see, we have information about the IP address of that container, or the exposed ports, or the image that it's running, the container name, container ID, all that, also labels. With this information, for every event in the Docker infrastructure, we check the conditions that you gave us in the configuration. So in case it matches, like in this case, we can see the Docker container image is etcd. So our condition in the previous configuration will match this auto-discover event. Then we take the configuration template from the settings you gave us and do bar expansion on it. And this is where the magic happens and what allows you to define really dynamic environments. We are taking information, live information from the system, from the event that just happened, like a container started, and we are replacing the information that we need into a new configuration. In this case, the configuration needed to know the IP address of the container. We take it from the auto-discover event and put it in there through the bar expansion. That will create a full qualified configuration that you can launch, or metric bit will launch for you. And this works both when you start a container and when you stop it. So if a container stops, auto-discover will detect that event and go over the same process, but instead of launching the module, will stop it for you. So you don't need to care about what's going on. You just need to define the desired states you want, the conditions you want to match. We recently launched this also for Kubernetes in 6.2, so you can do the same. And as with Kubernetes, you have things like annotations. You can do even more magic here. In this example, this one is for file bits. Previous one was for metric bit. In this case, what we are doing is using annotations. And actually, I have to say that I took this idea from the Disqus forum today. So thank you. Basically, what we are doing here is taking the annotations from the pod definition. And if you have an annotation called harvest, this could be anything defined by you. We want to match that. And if we see that the annotation for harvest, the value is true, we want to launch the Docker prospector to read the log from that pod. What this is doing basically is to allow you to invert the control on how your logging works. And instead of defining everything in the file bit file, you can define how your logging works from the Kubernetes annotations. So you don't need to update the configuration file of file bit, just include the annotation to harvest or not the logs for this container. And that will be everything you need to tell FileBit that you want the logs from this container or you don't want them. Sometimes we have noisy containers whose logs we don't care about. This is a good way of leveraging auto-discover to silence them and ignoring them. This was the full set of tools that we provide, or primitives that we provide in the configuration of bits. Now let's see how we will normally deploy this and what are the best deployment strategies for both for FileBit, MetricBit, and the rest of the bits. Let's start with a common Docker host. This is just one machine running Docker and many containers on top of it. If you want to get metrics from this infrastructure, you will use MetricBit. And something that we normally recommend is to run bits inside another container. So it will run along with your applications in a different container. But as we want to monitor both the host, Docker API, and also your applications, sometimes we need to mount some information from the file system, from the host system. In this case, we are mounting the proc file system, so we get access to all the information of the processes running in the host, and also performance and so on. The same goes for FileBit. You would run it in a Docker container, but we want to mount the barlib Docker containers folder because there is where Docker stores the logs from all the running containers. So then we get access to that folder, and we can read the logs from there and enrich them using the metadata processors. We will see this in the demo. When you are doing the same thing on Kubernetes, it was in the very same way. You want to launch them in containers, but Kubernetes gives you tools to do this. In this case, you could use a daemon set to ensure that we get one container of FileBit or MetricBit or any other bit per node in the cluster. So all of them get information from their node and all the containers running in their node. But the way all this is documented, you can go to our webpage and the documentation in the bits documentation, and you will get an example manifest on how to launch this daemon set. So we have examples for FileBit and MetricBit. It's really easy to get going. If you download them, just put the credentials and the URL for your Elasticsearch, and that's all you need to start monitoring and retrieving logs from your Kubernetes. We are about to see that. So yeah, demo time. Let's see how all these primitives I saw work. Yeah. This is the demo application I'm showing. Basically, we are running something like 3 pods. I think it was 3 pods with a Python application written in Django and an Nginx working as the frontend for that application. and MySQL in the back storing everything. You can go to that URL. It's a silly application just for demo purposes. The idea is that you can write there your favorite feature of the Elastic Stack and also both the submissions by other people. So I don't know, we do like an funny ranking, but it's only for having an application that I'm running as of now within a Kubernetes cluster, and we will see how we can monitor it using both FileBit, MetricBit, and also PacketBit. So let's go for it. First of all, the application. Probably some of you already saw it. Yeah, thank you. The idea is simple. You can submit a feature that you like here, put your name and both others. So for instance, I like Bit Auto Discover, my name is Carlos, and I submit that. And I can also vote the ones I want. And let's see how we can monitor this application. I'm running an Elastic cluster in Elastic Cloud. It's already deployed. I'm basically using this to retrieve all the metrics and logs, but this could be either another cluster in cloud, but also in on-premises if you are using Elasticsearch. So this is it. We can see that in my FileBit index, there are no logs at the moment. Let's see how we can start retrieving logs from my application. I have a couple of manifests here. All of them are based in the ones that you can find in the documentation, but I did some changes for demo purposes, and I will go over them. First of all, I'm going to show how is my application deployed. You can see it here. We have a MySQL pod and 3 Bits demo pods. These Bits demo are made of 2 different containers. One of them is running the Python Django application, and the other is an Nginx frontend. We could see also the deployments for them. So yeah, they are. I have a Bits demo with 3 replicas and a MySQL. Let's go to getting the logs. Okay, this is the FileBit manifest that I'm about to deploy. As I said, it's very similar to what you will find in the documentation, but I edited already some bits to connect to my specific cluster. First thing we notice is these lines, and this is instructing FileBit to retrieve all the logs from all the containers running in my Kubernetes. This star could be a container ID, a specific container ID, but I want to retrieve everything, so I can use that. I'm also using Autodiscover. In this case, I'm interested in data engines that I know it's running, so I put a condition here that says if you see a container running Nginx, I want you to launch the FileBit module to monitor or to process the logs from Nginx. So this way, I'm not only getting the raw logs from Nginx, but I'm also doing some parsing of them in the ingest node in Elasticsearch and getting structured that data from these Nginx logs. And that's pretty cool because then I can do more analysis on them. And also, of course, I almost forgot, we have the processors adding all the metadata we want to everything this FileBit sends to Elasticsearch. Let's get it deployed. As you can see, it's really easy to get started. As I said, we provide with this manifest, so you only need to deploy it like this after updating it with the information about the host. And the first thing we see is that it has already started to send logs. That's cool. It's working. The first thing that we see is that it backfill information from the past. And this is thanks to the Docker prospector. We are able to get the timestamp from the Docker log files, so we are able to put them in the right moment where the log line happened and nowhere, not where we read them. So this is cool. I got a bunch of log lines from all my containers, and that's cool. But I want to be able to read them per container, or maybe focus on one of them if something's going on. That's why we want all this metadata and why it's so important. So I'm going to add this metadata to the columns so we can see how that works. So for instance, the pod name I'm interested on, the namespace, and maybe the container name. So look at this. Now I know not only getting the log line, but also really useful information about that log line, where it came from. Let me pause this for a moment so we don't get new updates. For instance, on this document, I can see all the metadata that I'm getting, thank you to using processors, apart from the log line. And for instance, this is telling me that this is an Nginx. It's actually this Nginx, the one running within this pod. So this allows me to navigate the logs in a really cool way. For instance, if I want to see all the logs by Nginx, I only need to do this. And I'm getting now all the logs from your real-time visits. So this is what's going on now. And I can see that there are 3 different pods sending logs about or from Nginx, because I have 3 different Nginx working. And for instance, if I want to focus only one of them, I can do that too. Thank you to metadata. Yeah, I think this is really important when you want to navigate your logs, because it allows you to focus on what you want or retrieve all the logs from Nginx from any container. Cool. And as I said, we are using Autodiscover. Now I'm interested in looking into my logs and see what's going on with Autodiscover. I just write Autodiscover here because I know that FileBit logs something about Autodiscover, and I see what's happening now. Basically, FileBit is telling me that it discovered that there is an Nginx running, and it launched the Nginx module for me. And this was dynamic. I didn't hardcode the Nginx configuration. I'm telling FileBit only, if you see an Nginx, I want to use the module for it. What I get using that is this cool dashboard. Apart from all the metrics, of course, this is a dashboard made from them that gives me real-time information of all the visits that I'm having in my application. So as you can see, I can see all the errors that were happening, and also get a nice map of where are you based, all the things that you are voting from the access log, and on all the pages that you are visiting, basically, and some useful information from the user agents. All this comes from FileBit and from processing these logs from Nginx. And again, it's really cool to have metadata, because that way I can focus. I can get these logs and filter them if I want. So for instance, I can filter by pod name, and if I'm interested only in one of them, in one of the, let me check if I can do this. Sorry, I don't remember the name of my Nginx instances. Okay, I will show this later because I have a dashboard prepared for it. But the idea is that I can filter the logs, and also in this dashboard, because everything is annotated with this metadata, and get the information not only for the whole infrastructure, but for something that I'm interested on, like a single container. We'll see that later. Cool, that was for logs. Let's go to metrics now. We will use MetricWith for that. And this is the manifest file. Again, we have an example manifest in our documentation, and I updated it just to do some auto-discover and so on. First of all, we want to get information from the system, so we enable the system module. That's easy. This comes by default. We do the same for Docker. We want to get information from the Docker daemon. So that will give you information about the performance of all the containers, what's going on. And also from Kubernetes, I want to enable the Kubernetes module, so I get information about Kubernetes and all that layer. And as I said, we are monitoring the 3 different layers of this infrastructure: the system, the Docker containers layer, and the orchestrator, Kubernetes. And also I'm using Autodiscover because I'm interested in retrieving information from my MySQL. I know that I have some MySQL instances in my cluster, so I configure Autodiscover to fetch information from them to monitor. Basically, same pattern. I'm using the container name. If it contains MySQL, I'm launching the MetricBit MySQL module to monitor it. And I'm actually doing the same for Nginx. So I'm using the status service in the Nginx to get to monitor it. Let's get this deployed. Again, as you can see, it's really easy to get started. All the dashboards that I'm showing come by default, except the last one, I will tell you. So it's really easy to launch this and go to the dashboard and see an overview of your system. Let's start with the system module. MetricBit should be deployed already. So yeah, we are getting metrics already. I just launched it, I'm starting to get metrics. So in this case, there is no way I can backfill this like with the logs that are in the disk. But as you can see, I'm getting information from my 3 hosts in the cluster. I know that this cluster is made of 3 different virtual machines, and I'm getting information for all of them. And I'm guessing this is the one that's running MySQL, because if you take a look to the memory usage, this is the one that is consuming the most. And I know that MySQL is running, when it's running, it's taking a lot of memory. So I'm going into that server, and I get more details about it, especially in the performance side. So yeah, business as usual. I get a lot of information, really useful about CPU, memory, and so on. And here is my process list for that host. And yeah, there it is, MySQL, as I predicted. Let's go now to the Kubernetes layer. This is an interesting dashboard because it gives you an idea not only about the performance, which is there too, but also about the state. So as you see, I just deployed this, and I already know that I have 3 nodes, 10 deployments, and 3 pods running in my cluster. And you can see here that all my deployments are doing well. All of them have all their pods available because this is 0. And then I get information about the performance. Probably this cluster is too big for a single application and a small silly application. But yeah, that's why I get that my limits on CPU are way above the real usage that I'm doing. And yeah, I can get many insights about the performance of all my containers. In this case, I can see the CPU that they are using at memory. This is just a dashboard, but we are sending all these metrics to Elasticsearch. So you could build your own dashboards for this case. And I did that, actually. I created a dashboard for this webinar to show the power of metadata. This is what I was trying to do with the Nginx view, but I didn't remember the name of my pods. So what I did here is create a new dashboard. Here created a pods view. Like, it gives me in the internal rings, it gives me the namespace, then the pod names, and then the containers running within that pods. This is an interesting view because it gives me a lot of information about what's going on in my cluster, especially what I'm running. And here I have information both from FileBit, like the map and this visits list, and also from MetricBit about the performance. And here I also have the logs for this whole namespace. And I think this is really cool. And this is where having everything in one place helps you a lot. And having the right metadata to navigate this information is really powerful. So for instance, we can see in this dashboard that I'm filtering to the Kubernetes namespace default. But I can disable this filter, and I will get information about my whole cluster, including the kube system namespace that is here. So I can see everything that is running in my cluster here. And if I want to focus back in my default namespace where my application is running, I just have to click there or enable this, and that will focus there. So when I'm doing that change, I'm changing also all the views in the dashboard. So for instance, these logs are all the logs I got from my namespace. But if I want to focus only in the logs from this pod, this specific pod, I can do that. Just by clicking here, now I'm seeing all the logs for my pod, only for this pod, and the same for the map of visits and the Nginx status responses and CPU usage. So in this case, we are seeing that all these requests were served by this pod and only this pod. I can remove this filter, and I see that now I'm seeing all the different requests and all the different logs. And this is the power of metadata. It allows me to, in a very easy way, navigate all the information I got. Yeah, and I think this was everything I wanted to show today. So yeah, maybe, Brando, we can go to the questions if people have some.
Yeah, that sounds great. Thanks so much for that, Carlos. It's really awesome stuff. So yeah, we want to go through and just take a few minutes for questions. I realize we may not get to everything here in the time allotted, but I saw some great chat and was helping answering some questions there. So the first question that I wanted to dig into was actually about deployment. So as you talked about a bit, deployment as a daemon set with Kubernetes means that you'll get one pod for the beat on each node, and then it'll collect from all of those. But the additional detail in this question is about how many beats processes, how many will you get when you have 100 Nginx pods on a node. And perhaps, Carlos, you can talk through like, how do you configure that? And then what happens when you have multiple of a particular type configured?
Yeah, that's a very good question. So the thing here is that if you want to launch one metric bit instance to monitor each Nginx, that wouldn't scale, because that will mean that you need to launch one process per things that you're running in your node, and that doesn't scale. What we do is having a single instance of the agents, it may be file bit, packet bit, whatever, metric bit, and that single instance is able to talk to all your services in the node. I think it's the right compromise to put that one per node, so it doesn't get preloaded. If you think of one instance for the whole cluster, that may not scale, because that instance will need to talk to too many nodes and too many services. But if you have one per node, that scales very well. And also in some cases, like system information, you need to be in the node. So
awesome, cool. So next question here is actually about how auto discovery works with modules, and really specifically, how difficult is it to implement your own module to work with auto discovery?
Cool. Basically, we are using stock modules from MetricBit and FileBit, so you don't need to do anything specific for auto discover. If we have a module for the service, you can use it in auto discover, and that's cool. We have guides on how to implement new modules. You can go to our documentation, and both for FileBit, MetricBit, and the others. I think it's really easy, so I recommend everyone interested in taking a look. Also, if you have some doubts, you can go to discuss and ask there. We have an active community of developers that is growing, and I hope that if you join, it will grow even more.
All right, so the next one is a little different in terms of topic. So I'll read the question here. It's from earlier in the IRC. I realize lots of folks are trying to ask questions. We'll try to collate a few more in here. Don't worry. We'll get to you in the chat if not. So the question is, I have FileBeat streaming Docker enhanced logs, just as discussed. So this is from earlier in the presentation. However, now I have the issue with huge log files and no rotation. Is that a problem that's solved? Otherwise, I have to work around it. And so in particular, this user points out, unlike in Carlos's example, I'm single host Docker composing at the moment with migration to Swarm coming later.
Okay, sorry, what was the question? Sorry, I was reading.
Yeah, no, that's okay. So the question is essentially about log rotation with enhanced Docker enhanced logs. So that may be just something that is a configuration chain thing you need to make, because the FileBeat itself, of course, won't rotate or delete logs on its own.
Yeah, basically, FileBeat is able to detect rotation and take care of it. So it will keep going with the old file until it sends it completely, and will start with a new one.
So in that case, would the user just have to configure rotation then? Is that what's missing?
Well, yeah, I mean, you have to configure rotation for your Docker daemon. Like if you are using the JSON file, by default, depending on your distribution, it doesn't have rotation configured, and definitely you should do it, because if you don't, it will fill up your disk. But yeah, this is Docker configuration.
Cool. Do you see another question that you want to pick out of there? Otherwise, I can keep giving you some more that I see.
Yeah, let's take a last one. I saw an interesting one. Someone asked what's the difference between using the file prospector to retrieve logs that, as you normally will do with previous versions, with 6.1, for instance. What's the benefit of using the Docker prospector? The thing with the Docker prospector is that we are parsing information from the file. You will do that using the decode JSON processor in the past, but thanks to the Docker prospector, we are able to do things like retrieving the timestamp. So do this backfilling that you saw during the demo. So we are able to read the file at any moment and put it in the right moment where the log line happened. And also, it solves for you the problem of JSON inside JSON. Imagine that your application is logging in a JSON format, and then everything ends up written by Docker in another JSON document. So you will have a JSON document inside a JSON document. The Docker prospector takes care of the first the JSON layer, so you can use the JSON parameters we have with the file prospector and others to decode the real message, what you are expecting. Also, if you are doing multi-line, for instance, you can compact many different lines using the multi-line patterns. The Docker prospector makes it possible. So definitely, if you are getting logs from the log files written by Docker, I definitely recommend using it.
Cool. All right. So I realize that there are more questions coming up there, and Carlos and I are going to spend a little time here right after addressing some of those questions live in the chat. So we'll be around there for a little bit. I do want to show a couple more slides and thank everyone here. We're going to do a little bit of a quick wrap up. So let me just tell you a little bit about Elasticon, if you haven't heard about it. This is our big conference here in San Francisco, or at least that's where I am at the moment. Carlos, of course, is over in Spain. This is a meeting of all of you, really, along with us. So we bring in tons and tons of people from around the world, as well as the whole of our engineering team, to meet with you for a couple of days. There are tons of presenters from the community, from our customers. There's the Ask Me Anything station, which is huge, and we'll be there to answer all of your questions live. So this is really great. If you haven't been able to come to one of these before, highly recommend it. It's a really great meeting of everyone, and you can learn about it more from our website at the Elasticon Conf 2018. Just go to our website and click on Elasticon. You can get to there. And last but not least, to thank everyone, let us remind you of our many links to things to follow up with us. There's, of course, elastic.co. You can read more about our products. You can talk to us on the Discuss forums at great length. There's the community meetups, which, of course, many of you are participating in or running. So thank you very much for that. And, of course, you can get to us at Elastic on Twitter. So thanks, everyone, so much for joining us today. Again, we'll be in the IRC chat for a little while longer to wrap up some of those questions and provide folks some follow-up links and whatnot.